Hey everybody, I'm Marty Jacobson here in my shop in Atlanta, Georgia. I've got this Kentucky KM-140 model. We've leveled the frets, we've dressed the fret ends, and we've crowned the frets. All it needs is a bridge, a nut that's set up properly, and a set of strings, and it'll be in great shape. So we need to talk about string geometry. String geometry is not an intuitive topic, but you got to understand it in order to do a good setup. It relates to fretwork and the design of the instrument itself.
Here's the general idea. We have a mandolin, and the strings are affixed to the tuners and the tailpiece, but that's not where we want the string to be stopped. The strings must be precisely stopped between the nut and the bridge, and this is called the scale length. And if that isn't set up exactly right, with a nice sharp knife edge on both the bridge and the nut, we'll get buzzing and intonation issues. The mandolin we're working on right now came from the factory looking like this, with the nut and the bridge very high. Setup is an optimization exercise because if it also gets too low, then that can be just as bad as it being too high because it'll buzz against the frets. This is a gross oversimplification because it's actually a three-dimensional system and can warp and twist and have relief and be conical and a lot of other things that we don't have time to get into here. Long story short, our goals for a basic mandolin setup is to get between 0.1 millimeters at the first fret, between the strings and the first fret, and about 1 to 1.5 millimeters between the strings and the 12th fret. The easiest way to deal with relief on a mandolin is to make sure that the neck is stiff enough and level it dead flat before applying strings, and you should get just enough relief, which is a tiny bit, almost none. So our next setup task is to determine what the final height of the bridge should be, to determine the lowest position the bridge would need to be. The plane of the fretboard, as you can see, intersects with the bridge, so there's no way to set this up properly. So I'm going to use the new bridge base and try to figure out what the difference should be so I can determine how thick to make the new bridge saddle. To start out with, I'm going to use the string height gauge and a ruler and figure out what my theoretical lowest point needs to be. That's 5/8 of an inch, 625 thousandths of an inch, or 16 millimeters. You can use whichever units make you feel the proudest. Just looking to see what I got to work with. The existing bridge is about 1/8 of an inch or 3 millimeters too thick. Now I'm going to take the original saddle and try to make a decision about whether I think I have enough meat on it for it to be structurally sound for a long time after we remove this amount of material. Running through the options, we can make a one-piece non-adjustable bridge. We can cut down a Stumac or similar ebony bridge. We can ask Cumberland Acoustics or Vern Brecky to make us a bridge that's low enough. I'm going to use one of my bridges, which has a beam that's taller than you could normally fit in a traditional appearance adjustable mandolin bridge while being this low. But really, any of those options will work as long as they're designed to work in this application. Mirka ProFlex sandpaper is awesome for this because it conforms well. I brush off the back of it to make sure there's no grit from the package. It's really annoying to end up scuffing up a mandolin top using the sandpaper. You want to get all the grit off of it. I then use a ruler that's marked like a story stick so I know exactly where the bridge is going to be, or at least close enough. And then instead of using a jig to fit the bridge, I like to make sure that the sandpaper is tightly conforming to the top, and then I just make sure that the bridge is oriented in the right direction and slide it from side to side along the contour. My goal here is not to remove all the material with the sandpaper. My goal is to mark the bridge with the sandpaper. To avoid creating gaps at the extreme ends of the bridge, you really need to hold down the sandpaper tightly so that it doesn't flip up every time you slide it back and forth. A few strokes, and as you can see, the progress that's been made is extremely unambiguous. I've marked it here with Sharpie to make it show up better on the video. So I'm not going to show you every minute of this. It's not a complicated process. You mark and then scrape where the high spots are. Use the sandpaper again, mark where the high spots are. Make sure that you're putting it back in the same place and that you are looking at the bridge without the sandpaper in place periodically, because one of the things that you need to do is kind of look at how the shape of the top is reacting to the bridge. I also like to put a little bit of pressure down on the bridge because sometimes the top and the bridge can flex significantly, and that might impact the way you shape it. For example, you might put a little bit of spring in it so that it can conform to the top when the top deforms a little bit under string tension. So the key skill here is attention to detail. There's no one jig or technique, there's no magic bullet. It's just you looking at the top, applying pressure, seeing where it doesn't make good contact, and then scraping or sanding until it does. Make sure that you constantly look at where the bridge is positioned because you can get way off. Just look, scrape, measure, and repeat until it looks good. What is not ideal is that there are two pretty substantial divots from the poorly fit old bridge on either side of the center line. Maybe those will smooth out. I have the new bridge touching at both ends of the bridge and all the way through the middle except for where those two little divots are. So maybe it'll all smooth out over time, or maybe at least because it's supported in the middle, it won't progress further. So I've fit this as well as I believe I can at this point. The only other option would be to do a very complicated chalk fitting process or to use the epoxy bridge fitting trick, which I'm not a fan of. Just checking to make sure this mandolin's in tune with the universe. It seems to be. Now I've got to modify the bridge saddle to make it flat because it started out radiused, compensated, and as short as possible. This is not supposed to be an ad for my bridges, but this bridge ended up needing to be just a little bit over a half an inch tall, and I didn't feel comfortable using that original spongy rosewood bridge to do that. The carbon fiber insert does not prevent my bridge from being adjustable, but it goes all the way down to the base of the bridge. Compare this. This is the original bridge, and imagine removing that much material from that spongy rosewood bridge. There's no way it would have held up. I want to draw your attention to the triangular bridge and nut representation. It's drawn that way for a reason, because if you think about it, if there's a flat surface that the string bends along, then you'll probably see buzzing, binding, and tuning issues. If you've ever had a string get stuck in a nut slot as you tuned it and kind of squeak as it snaps into tension, that's because it didn't have this V-shaped nut slot groove. So I'm going to use a triangular file, the tip of which is exactly the same size as the string, ideally, and I want to make a V-shaped groove that tapers outward and down so that the string bends over, ideally as close as possible to a knife edge that still holds the string exactly where it needs to be. I don't have V-shaped files in all the right sizes for the string, so I'll often use a gauged file and cut to the right depth with the gauge file, and it's going to be kind of a straight slot. So what I'll do then is I'll take a round or triangular file and kind of relieve the back side of the nut slot so that it's smooth, almost like a funnel that's guiding the string into the exact right slot. And then just the very end, at the very face where the nut ends, it'll be exactly the right size with the gauged file. And then I'll check the height using a razor blade, and I just want the piece of paper to just barely drag on the first fret when the razor blade is resting in the nut slot between the nut and the second fret. A much more efficient way to do it would be to measure the height of the fret exactly and then use a feeler gauge that's the same height and cut the nut slot to that depth. You'll still probably have to cut it a little bit lower later, but my paper and razor blade trick guarantees that I have plenty of meat to file later. Easiest way to get the bridge in the right position without marking or marring the top is to install just the outermost strings, the lowest G and the highest E string. With these two strings in place, you only have about 4 or 5 downward pounds of pressure on the mandolin top, and you can easily slide the bridge around, and you also don't have to tune and detune a bunch of times. So it helps you check whether the bridge is in the right place very efficiently and quickly. I also set the action there because the outermost strings are what determine your action. Everything else is going to be dependent on that. So roughly set your action there to be about 1.5 millimeters on the G course and about 1 to 1.25 millimeters on the E course, if you can get away with it. I always get carried away playing a newly strung up instrument with just the G and E strings. It's kind of a quirk of mine. What I'm really doing here is checking to see if there's going to be any issues with intonation or fretwork that might show up later. The low G string and the high E string are your extremes, and so if nothing's showing up there and you get all those issues resolved that might crop up, everything else should be in good shape. Oh yeah, you'll see me adjusting the action under full tension using this little wrench. That's because I have hex nuts on my bridge posts, You can do the same thing with just the G and E string installed. That's another big reason why you might want to do this. You can adjust the thumb screws under full tension, no problem, with just the G and the E string installed and tuned up to pitch. When you got the action and the intonation all dialed in and you like what you're hearing, go ahead and add all the rest of the strings. I start by adding the G and E string that are remaining to try to keep the tension balanced. You don't want to just load up one side of the bridge. It'll either fall over or shift to the side, marking your top. The easiest way to install strings so that you don't need a string winder, especially the plain steel strings, is to orient the hole in the tuner so that the string can go through slack without being bent one way or the other, just straight up and down. Slide the string through there, and then you're going to bring the string towards you and then loop it underneath the string. Then you're going to pull it back around and up so that the other part of the string bites down on it, and then loop it back around and hold it in your hand. Apply a little bit of tension upwards on both ends so that it doesn't flop around or come out of the little knot or kink that you've just made. And then 5 or 6, maybe half a dozen turns of the knob, and it's tight, and you can cut it off and not have to worry about it coming unraveled at all. Here's another view. Orient the string so that it just goes through slack, bring it back under and straight up, and then around the post, and then grab it in your other hand so that you don't get poked by the loose end of the string. And then less than 1 full turn of the tuner post, and it's tight, and you can cut it off without any worries. Now just load up the rest of the strings and periodically check to make sure the bridge hasn't rocked forward or slid around. Check the intonation, make sure the action's still working. The forces the bridge exerts on the top are going to cause it to deform a little bit, so watch out for that. See if there's any adjustments you need to make. Once it's settled in for a few minutes and the strings have kind of stretched out and gotten in tune, then I'll look at where the first fret is relative to the bottom of each string. At this point, if you use the razor blade and paper trick, it's probably quite high. And so the trick now is kind of a game of chicken to try to file down those nut slots to the point that you have the string as low as possible, but without it buzzing against the first fret. And so you just keep doing this until you feel like you've got it as low as it can go. There's not really a scientific way to do it. You can use feeler gauges, but the wound strings especially tend to wrap around the nut slot, and so it's very difficult to predict. Like, let's say you've got 30,000th tall frets. You could use a 15,000ths feeler gauge, and the G string probably will still be, 10, 15, 20 thousandths above the first fret. So it's highly unintuitive, and just go trial and error, a few file strokes at a time, check where you are, and when you are confident that you can't get it any lower without buzzing, then you stop. And if you make it buzz, then you make a new nut, and that's just how it goes. After sitting overnight, the 2 divots in the top have pretty much completely conformed to the new, smooth, curved base of the bridge. So that's good. I'm going to install leather underneath the tailpiece cover, and I'm going to weave some leather between the strings to try to keep it from being a whole separate instrument down there. So now it's nicely muted. And I'm going to put a little bit of leather, which super glue does not stick to, so I used a piece of double-sided tape, which, since it's going to be pinched in there, it'll be fine.
Okay, let's talk about what we ended up with. We ended up with nice low action, about 1.25 millimeters at the 12th fret, and nice and low at the nut. And it sounds pretty good. The real way to fix this, if this were an expensive instrument, would be to replace the fretboard with one that is wedged so that we could get a proper break angle and bridge height on this instrument. And at the same time, you would replace it with frets that are not tiny and already mostly used up, because that's what it took to level them. But this instrument is working now, and yeah, I'll take it. The thing you have to look out for is very possible to put in $500 worth of work to a $200 instrument, and you don't get a $700 instrument, you just get a playable $200 instrument. Hope this was helpful, and let me know if you have any comments. See ya.